Hey Maddie, here's a shout out to Maddie.
Hey, can you shout me out?
Okay.
Say Dipset.
Shouts to Stephen Kumar.
Okay, thanks.
John Blake.
Okay, let's be quiet. We're recording now. And so to calculate the probability of independent events that are not affected by their outcomes of each other, the probability of events of A and B occurring is as follows. Probability A and the probability of B is the probability of A times the probability of B. Which, so for instance, if the probability that it's going to rain, okay, is equal to 1/4, and the probability that that you get a new car for your birthday is new car is 1 out of
A million.
100, okay? And the probability that it will rain and
John, shut up. I know you'll get a car.
new car is 1/4 times 100, which is 1 out of 4,000. You guys understand? 400.
Yeah.
You get that?
Yeah.
So that's if things are independent if they don't count on each other. Dependent events. So the other way you see that is, I don't want to do all these problems with you, but it's with like marbles in a bowl, okay? So if they replace the marbles after you do an experiment, and then you do the experiment again, that's independent. If you do not replace the marbles, that's dependent. For instance, a bowl contains 5 red marbles, 6 green marbles, 9 blue marbles. If a marble is randomly picked, replaced, and a second is randomly picked, what is the probability that a blue marble is picked twice? So what's the probability that a blue marble will be picked on the first time?
9 out of 20.
9 out of 15, 20. What's the probability if I replace it that a marble is going to be picked the second time?
9 out of 20.
9 out of 20 again, okay?
Wow.
So altogether that's 81 out of 400 chance that you will pick a blue marble twice, okay? I don't want to,
Do you reduce that?
I don't think it reduces, doesn't reduce.
But what do you prefer?
I prefer to leave it as a fraction, okay? Or you can turn it into a percent if you want, okay? If it's not replaced, let's go back to this one, okay? What if I don't replace the blue marble?
Then it,
It's 9 out of 20 times what?
So
8 out of
19.
19, right?
problem.
This is, no, it's a different problem. This is without replacement. That's dependent, right? Because what happens before or after depends on what happened before. That's what like card counters do. They go to Las Vegas and they see how many aces have been dealt or how many jacks have been dealt or something, and then they try to count out
That's illegal.
and figure out their probabilities of winning. So I'll let you look at some of those other ones, okay? Then, whoops, is that the end of the sheet?
At the end of the sheet.
If that's the end of the sheet, so that's it?
Yep.
Yes, sir.
That's it on that side of the sheet?
Adding probabilities.
Okay. Multiplying probabilities, talked about that. Adding probabilities.
Hey,
So let's go to adding probabilities. And so adding probabilities, mutually exclusive events are events that cannot occur at the same time. The probability of 2 mutually exclusive events A and B occurring is the sum of their individual probabilities, okay? So, for instance, where did I come up for that one? And that's an OR. So say the probability of you, I don't know, winning,
The lottery.
getting a full house, getting probability of getting a red marble. Let's just red marble out of a bag is 2 out of 3, okay? probability of you getting a green marble out of a bag is 1 out of 4. What's the probability of getting a red or a green?
3 out of 12.
You add those two fractions together, okay? And so you gotta be, kind of use a common denominator. So this is 2/3 plus 1/4, which is 12ths, right? So that's 8/12 plus 3/12, is that right? Which is 11/12 of the time. You're gonna get red or green,
Oh,
right?
it's not time, it's plus.
Yeah,
Yeah.
you just said you add them, I'm confused.
You add them if it says if
No,
it
no,
says
we multiplied the
or.
denominators.
If it says or, then you add it, okay? So what's the probability that you're gonna get this or
That makes sense.
you're gonna get that? Then you add it.
Yeah,
Okay?
but how'd you get the 12?
When I get 12, I multiply 2/3 by 4/4.
So you really don't add, you all
And I multiply this by 3/3. No, I'm finding a common denominator. 2/3 is equal to 8/12, right? 1/4 is equal to 3/12. 8/12 plus 3/12 is 11/12. So 11/12 of the time, if the probability of getting a red is 2/3, and the probability of getting a green is 1/4, then the probability of getting a red or a green is 11/12, right? You understand that? If you're rolling a dice, what's the probability of getting a heads? Or flipping a coin, sorry.
0 out of 0.
What's the probability of flipping a coin? Sorry.
1 out of 2.
What's the probability of getting a heads if you flip a coin?
1 out of 2.
1 out of 2. What's the probability of getting a tails if you flip a coin?
4 out of 1.
What's the probability of getting a heads or a tails?
2 out of 2.
100.
2 out of 2. 2 out of 2 or 1 out of 1. 2 out of 2. What's the probability of getting, so if you flip 2 coins, what's the probability of getting a heads then a tail?
1 out of 4.
A heads then a tail. Then you multiply the probability, right? 1/2 times 1/2, which is 1/4. You see that?
Damn, Mr. Lee.
So if it says this, then that, then you multiply. It says this and that, then you add. Now, sometimes probabilities overlap, okay? For instance, I came up with one. So, right, I'm going to just grab this. Okay, so inclusive events are events that can occur at the same time. The probability of 2 inclusive events occurring at the sum is the sum of their individual decreased by the probability that both occur. For instance, the probability that someone in the class plays a sport, okay, let's say that's 3 out of 10, okay? The probability that they play an instrument is, let's say that
6 out of 9.
that's equal to 4 out of 10.
No, 4 out of 20.
Probability
4 to 9.
probability that they play both is equal to, let's say that that's 2 out of 10, okay? So the probability that they play either, that they're either in a sport or play an instrument is gonna be 3 out of 10 plus, I meant to write 4 out of 10 just to make life easier. 3 out of 10 plus 4 out of 10 minus 2 out of 10. You understand why that is? Okay, so that's equal to 3 out of 10, 4 out of 10, that would be how many out of 10? How many out of 10 would that have to be? 5 out of 10. Now, you could represent that with a Venn diagram, okay? Because, remember, do you know about Venn diagrams? So here's all the people in here, right? Oops, that's not very good.
I don't like
I can write it. So look, altogether, I have 10 people, right? I have some people who, so here's the people who do sports, here's the people who do instruments, okay? Altogether, I have 10 people. So in here, I'm going to have person A, person B, right? But, so there's some people who both play a sport and play an instrument. People play a sport, there's altogether, person 3 is over here, okay? Person who plays an instrument, there's 4 people who play an instrument. So there's D and E over here. So, wait, how do I get 10? 3 out of 10. 3 out of 10. 2 out of 10 play both. Yeah, oh, so there must be some people floating around out here. Okay? So here's F and G, and H and I. So there's some other people out of here, right? So the probability that they play both is 2 out of 10, because there's also some people playing no instrument, okay? So 1, 2, 3, 4, 5 people in here.
3 people.
So there's 5 people outside.
There's only one person in the sports bar.
What? No, there's 3 people in the sports team. So,
How's there 3?
so here's the whole, all the people, right? There's 5 people don't play anything. So there's F, G, H, I, J, and K are floating around out here. So 3 out of 10 people, these are the sports people, right? These people, 4 out of the 10 people, these are the instrument people. These people are the 2 people who play both, right? So in order to figure out the probability that they do either or, you're in here or you're in here. Well, I add together 3 plus 4, right? But then I have to subtract the overlap because I'm counting these people twice. See that? So altogether there's 5 out of 10 people to play this. Yes? Sure? Did you follow that? Okay. So I'll let you work on some of these, at least 2 twos. What else? And then I real quick want to talk about expected value. Okay. Simply say that expected value of a game event is a probability event of winning the payout of the prize. For example, if the probability of winning a carnival game is 2/3, and the prize for winning the game is $5, then the expected value is 2/3 times 5, which is $3.33. Right? So each time you play, on average, you're gonna win $3.33. Therefore, if the cost of playing the game is less than $3.33, then the game favors the player, right? If that cost of the game is $5, who's going to make money? The casino, whoever's running the game, right? That's how casinos figure it out. They say, okay, I have a slot machine. This person's going to win an expected value of 30 cents, if they're for their dollar, right? And then so they're making 70 cents over time, even though sometimes people win $100, right? Over time, they're only going to win, 1/1000th of the time or something. Anyway, so that's how you find expected value. And I'm kind of done, and you can try to work on the rest of this worksheet. Do as best as you can on this second part, because this is kind of tricky, this game.
That's what I'm on.
Okay? Yeah, I want you to try to do this tomorrow. No, that's not you, that's my other class. All of them.
You just do.
Pretty sweet movie.
Sure. Okay, get to work. Put your phones away.
Hey, Jared, can you put that up in the corner right there?
Me permite agua, por favor?
Can you
If
get
you're back in
Pepsi?
like 3 minutes, not 15 minutes, I pull you over.
Mr. Leader. I don't know if that's actually right now.
Can you believe I'm understanding this correctly?
Sure. Let me just put these in my inbox with my other 250,000 things.
Oh my god.
Oh my God, you could just call me Mr. Leader.
What if I call you Kenny?
Oh!
Hey, Kenny G.
I forgot.
Mr. Leader, what if I kept calling you Kenny?
No, that's inappropriate. Because